Welcome to Unconventionally Python. This presentation is about decision-making structures. Usually, and by design, the computer executes one Python command line at a time from top to bottom, but often the computer has to make a decision, a choice to execute or not execute some code. Needless to say, that it is the program that directs the computer to do one thing or another. And we have seen previously a scenario that a ball is painted red or blue. So let's revisit that old scenario. In the previous presentation, we described the accessors and mutators, and we used the same example that you see now on the screen, in which the ball changes color to red or blue. Furthermore, the new color depends whether we click to the right of the ball or to the left of the ball. Thus, the question becomes, how would the system make a choice to paint the ball blue or red? Like any other programming language, Python has a structure, a mechanism by which the system can decide to do something or not. In general, and in its simplest form, we can say via Python something like, if a condition does exist, do X, Y, Z. This kind of logic is implemented here. Let's take a look at the program, the Python code that we see at the right of the screen. Lines 11 and 12 create the window. Lines 15, 16, and 17 create the circled Q, we will call it the ball, and the center of the ball is placed at the x-coordinate 400. At line 19, the getMouse method suspends the program execution and waits for the user to click the mouse. If I click now, the ball should become red, and here is why. Line 19 gets the coordinates of the mouse, and since the mouse pointer is to the right of the ball, we know that the mouse point x-coordinate will be bigger than 400. At line 21, this x-coordinate value will be assigned to the variable x of spot. Line 23 is where the decision-making process begins. We start with the if keyword, and then the if is followed by a Boolean expression, a condition. A Boolean expression in its simplest form contains a value, then a Boolean operator, and then another value. In this example, we have a variable, then a greater than symbol, one of the Boolean operators, and then a second value. Boolean expressions are either true or false, which is the same or the equivalent to yes or no. Just to simplify things, the computer poses a question to itself if the Boolean expression is true or false. In our example, the computer asks, is the value of x of spot variable bigger than 400? The answer is yes, equivalent to true. When the answer to a Boolean question is true, or yes, the system executes the command or commands below the if statement, and those statements have to be indented. It is important to have the colon at the end of the if statement and indent all the Python code you wish to execute when the condition, the Boolean expression, is true. Whenever, though, the Boolean expression is false, the system will skip all the indented statements and will go to the first not indented statement below the if line. In our example, it will go to line 26. So I click now, and indeed the ball turns to red. Let's see what happened. The system after that went to line 26 and tested the condition. That condition was false because the value of the x spot is not less than 400, and therefore, because the statement, the Boolean expression in line 26 was false, the system skipped line 27 and went to line 28, which is the end of this program. That is for the moment about decision-making structures and simple decisions. We'll elaborate at another time, and thank you for watching Unconventionally Python.